Hello and welcome to today's Thermo Fisher Scientific webinar. The title of today's webinar is The Application of Applied Biosystems VetMAX Xeno Internal Positive Control in qPCR Workflows. My name is Derek Grillo. I'm the Global Product Manager for our animal health business located here in Austin, Texas. And before I get started, I just wanted to take you briefly through today's agenda. I'm going to be kicking things off by giving a brief overview of the benefits of integrating VetMAX Xeno IPC into qPCR workflows for animal health. And then I'll be passing the ball over to Michelle Swimley. Michelle is going to give an overview of the performance of the Xeno IPC in variable thermal cycling conditions and enzymes. And then finally, Dr. Augustin Franco will be talking about his experience with incorporating VetMAX Xeno IPC into his lab's workflow to optimize a new extraction protocol and to accelerate the adoption of a new diagnostic assay. So before I get into the webinar, just a little bit of information to let you know that both Michelle and I will be leading a live Q&A at the conclusion of today's presentation. We hope that everybody can stay on the line for the duration of the webinar. Also, we ask and encourage you to submit any questions that you have throughout the webinar electronically, and we'll address those at the very end of the webinar. And just note that if your question happens to go unanswered during the live Q&A, somebody from our team will be more than happy to follow up directly with you via email and make sure that we've answered your question completely. And one other thing to note, we will be providing a very brief survey at the very end after the conclusion of the Q&A session. And the intent of this survey is just to get your feedback to make sure that future development of webinar content is best suited for you and for others looking to learn more through our webinar series. So that being said, I'd like to go ahead and start today's webinar. The timely diagnosis of one sick animal can often help to ensure the health of an entire herd. It can also protect a producer's livelihood, and certainly it can safeguard a lab's business. Oftentimes, workflow optimization is used to help stay ahead of the evolving disease landscape, but sometimes introducing changes to workflow can result in unwanted costs as well as complexities to existing diagnostic testing. So we've introduced a portfolio of internal positive controls to help in that workflow optimization. And this portfolio is called the VetMAX Xeno Internal Positive Control and Assay. And these are a set of exogenous IPCs which can be used to provide basically a complete solution to qualify the effectiveness of sample preparation as well as real-time PCR and RT-PCR workflows. These reagents enable the user to distinguish true target negatives from samples affected by PCR inhibition. They've been optimized for use with some of the most challenging animal sample types to be used as a positive control for the recovery of nucleic acids. The portfolio can be broken down into two subcomponents, the IPC and the assay. The Xeno IPC serves as an internal positive control for the nucleic acid extraction process. It can also be used to monitor for the presence of PCR inhibitors. The Xeno IPC is provided at a concentration of 10,000 copies per microliter, and it's available in both RNA and DNA. The Xeno IPC assay is a primer probe mix that's used to detect the Xeno IPC template. And in your workflows, the resultant Xeno data is then used to determine the validity of diagnostic test results. The assay is provided at a 25x concentration, and it's available in multiple dye options. Easily integrated in almost any qPCR workflow, the proprietary Xeno IPC assay offers labs a verification layer to help ensure that PCR test results delivered to customers are both accurate and actionable, and they do so by helping to reduce the likelihood of false negatives. Xeno IPC and Assays are effective mainly for three reasons. One, the portfolio is very flexible. Two, it's proven quality in a wide range of existing on-market solutions. And three, it's been proven to be compatible with a wide range of qPCR reagents. So Xeno can be incorporated really regardless of a lab size, the type of assay that's been designed, as well as the diagnostic strategy used in that lab. Available as individual internal positive controls and assays, the Xeno IPC provides labs with a flexible portfolio of solutions that includes both RNA and DNA IPCs, Applied Biosystems VIC and Liz dye channel formats, and multiple throughput kit options, which means we have both a 100 and 500 reaction kit size. Xeno provides labs with confidence in its performance and quality, really because it has a long history of use in our existing Applied Biosystems products for animal health, such as the Xeno IPC, which has been used for years now as a component used in our USDA licensed VetMAX Gold kits, as well as our VetMAX Plus reagents. And the Xeno IPC assay has been used for many years in our on-market VetMAX reagents. It's important to note that internal positive controls, including Xeno RNA and DNA, are recommended by the American Association of Veterinary Laboratory Diagnosticians, included in their guidelines for development and performance of PCR assays and veterinary diagnostic laboratories. And finally, Xeno can be incorporated into workflows very easily without disrupting or altering reagents that are already in use in your lab. The Xeno is compatible with a wide range of workflow reagents, including but not limited to the VetMAX sample prep portfolio, as well as other magnetic bead-based sample prep and spin column sample prep solutions. Our entire VetMAX reagent portfolio, as well as other laboratory prepared assays, and our entire portfolio of master mixes, including AgPath, PathID, and VetMAX Plus reagents, as well as a wide range of commercial master mixes on market and produced by other companies. Shortly, Michelle will be showing you some of the data we've generated that demonstrates Xeno's compatibility with other reagents. So with that, I would like to hand the ball over to Michelle. And Michelle is going to be talking about the performance of VetMAX Xeno IPC in variable thermal cycling conditions and enzymes. Michelle?
Thank you, Derek. Hello, everyone. My name is Michelle Swimley. I am a scientist here in the animal health R&D and was involved in the commercialization of these Xeno IPC products. Over the next 10 minutes, I hope to give you a brief introduction to Xeno and demonstrate to you how easily these products can be incorporated into any real-time PCR workflow. In terms of product design, as an exogenous control, the Xeno IPC sequence was designed to have no sequence similarity to any known DNA sequences that are publicly available in GenBank. In addition, the Xeno assay was designed to be highly specific for Xeno IPC to minimize the risk of any off-target amplification in a background of both host and pathogen-specific nucleic acids. The assay itself consists of primers and probes, which are provided at limiting concentrations in order to remain non-competitive with the amplification efficiency of the pathogen target assay. To ensure the accuracy of your test results, Xeno is used to add a layer of verification to your workflow by helping to reduce the likelihood of false negatives. It serves as both a control for the isolation method and is used to monitor for the presence of PCR inhibitors that are abundant in complex veterinary sample types such as oral fluids or feces. It can also be used as an amplification control for real-time PCR. This graph here shows the effect of increasing inhibition on both RNA target amplification and Xeno IPC. So as the concentration of the inhibitor hematin is increased along the x-axis, the amplification of Xeno follows the target's trend of increasing CT values, showing that it can be effectively used as an indicator of the PCR inhibition. So by helping to reduce the likelihood of false negatives, this gives the customer confidence that the real-time results are both accurate and actionable. Xeno IPC can be easily incorporated into any existing workflow for pathogen detection using real-time PCR. And it's added at 3 different stages throughout the workflow. So first, during sample prep, a known copy number of Xeno DNA or RNA is spiked directly into the lysis solution so that it is co-purified along with the target nucleic acids in the sample. A negative extraction control is also processed alongside the test samples, and this control will be used during data analysis to identify samples with PCR inhibitors and also to control for the recovery of nucleic acid. During the setup of the real-time PCR, the Xeno assay is added to the master mix that includes the pathogen target assay, and diluted Xeno DNA or RNA is also included on the run as an amplification control. Once the run is complete and the threshold settings have been set for the Xeno assay and each target assay, negative and low titer suspect samples with amplification between 37 and 40 CTs should be analyzed further for the presence of PCR inhibition. And this is essentially done by comparing amplification of Xeno IPC in the test sample to the negative extraction control. And the general rule of thumb here is that if there's a shift in Xeno CT greater than 1.5 relative to the control, PCR inhibition is likely present in the test sample. The graph on this slide shows the CT values obtained from isolation and amplification of Mycobacterium avium subspecies paratuberculosis and Xeno DNA, both from bovine fecal samples. So the map DNA is shown in blue and Xeno DNA is shown in red. I have also included 2 negative extraction controls that you can see on the far right of the graph, which I've abbreviated as NEC, and I've drawn a reference line to represent a 1.5 CT shift from the average CT of these 2 controls. So the purpose really of this graph is just to show you some examples of the types of results you might see during a normal run. Samples 1 and 3 are considered suspect samples because they appear map negative, but there's greater than a 1.5 CT shift in the Xeno CT. Sample 2 is an example of a map negative sample. Now, strong amplification signal for the target may also impact Xeno amplification, which is entirely expected given that the Xeno assay is a limiting reagent in the reaction. Examples of this can be seen in sample 4 and 6, but just remember that the results for Xeno are only relevant when the target is considered to be suspect or negative. So in these 2 examples, a delay in the CT for Xeno would actually have no impact on the final map results. To showcase how easily Xeno may be incorporated into any real-time PCR workflow, I wanted to show data that demonstrates the compatibility of the Xeno assay with a variety of commonly used thermal cycling conditions and enzymes. So the graphs here on this slide demonstrate the performance of the Xeno assay multiplexed with a complex pathogen target assay under variable thermal cycling conditions. The graph on the left represents Xeno RNA amplification using PathID multiplex one-step RT-PCR master mix. The graph on the right represents Xeno DNA amplification using our PathID qPCR master mix. Got CT values along the y-axis. The x-axis represents both copy number input of Xeno DNA or RNA from 10,000 copies to 100 copies, and that's along the top of the graph. And annealing time, which includes 30, 60, and 90 seconds, is displayed along the bottom of the graph. The colored bars represent different annealing temperatures that were tested in 2-degree increments ranging from 54 to 62 degrees. And all of these samples were tested in triplicate on a QuantStudio 5 real-time PCR instrument. So overall, the results show that robust amplification was obtained with these master mixes and that varying the thermocycling conditions had very little impact on Xeno amplification. These graphs here demonstrate the performance of Xeno assay with various master mixes. So they are similar in format to the graphs shown in the previous slide, except now in addition to varying the thermocycling conditions, several different master mixes were also tested. The colored dots represent the different master mixes used, which include both Thermo Fisher and other manufacturers. And then each data point represents a mean CT value for a range of annealing temperatures tested from 54 to 62 degrees. The results show that for the majority of the master mixes tested, there's little variation in CT values across the different annealing times for each input concentration. And the standard deviations are small, which indicates that varying the annealing temperature has very little impact on Xeno amplification. However, as you see with master mix E, Xeno DNA amplification is negatively impacted by changes in the annealing temperature. So in this case, when conditions are most stringent, the annealing performed at 62 and for 30 seconds. This resulted in a higher mean CT value and large standard deviations, as you can see in the graph on the right side. So now, although Xeno IPC should be compatible with just about any real-time PCR workflow, we do recommend that these products be evaluated with your existing qPCR workflow in order to ensure optimal performance. So by helping to reduce the likelihood of false negatives, Xeno IPC is used to provide confidence. The results are both accurate and actionable. This product demonstrates effective functionality, flexibility, and compatibility with a variety of qPCR reagents and thermocycling conditions so that it can be easily integrated into any real-time PCR workflow. For more information on how to incorporate this product into your specific workflow, please see the white paper on our website entitled Incorporating VetMAX Xeno IPC and Assay into Existing qPCR Workflows. This concludes my talk. Thank you for your attention.
Thank you very much, Michelle. And for the last and final portion of our webinar today, Dr. Agustin Franco will be giving a portion of the talk entitled Using VetMAX Xeno Internal Positive Control for Nucleic Acid Extraction from Various Specimens. Dr. Franco?
Thank you. The Vetnostics department at Laboratory Pathology has a molecular vetnostics section for the detection of infectious diseases, mostly in companion and production animals, such as dogs, cats, horses, etc. In the world of molecular diagnostics, the use of internal control is essential for quality control measures and good laboratory practices. There are basically two types of internal controls, endogenous and exogenous. The endogenous is a particular housekeeping gene present in the genome of the host sample. A major difficulty to acquire an endogenous control is that samples from different types of animals don't always share homology in these housekeeping genes. What I mean is that they might have a same gene, such as a beta-actin gene, but yet the DNA sequence is completely different. If we were to process many specimens from different sources, such as cat, dogs, and horses in the same extraction, it will be very difficult to use a beta-actin gene because obviously the gene will be different in these three animal types. Therefore, the use of an exogenous internal control become essential. These are either synthetic sequences or could also be that the sample is a spike with a DNA that is not normally found in the genome of the host. This talk will primarily deal with an exogenous type of internal control, such as the VetMAX Xeno RNA internal control. Feces, swabs, and bloods, or urines are resuspended in a buffer solution containing proteinase K. The aliquots are added directly to the 96 dead well plate, and an incubation step starts. Usually what we load is 150 microliters of the suspension, and using the VetMAX pathogen DNA and RNA kit. The Kingfisher Flex protocol has been optimized for the isolation of total nucleic acids from the sample types mentioned earlier. Each plate will have a specific reagent except for the wash buffers, which are in duplicate plates, and these are part of standard protocols. The protocol used in the lab involves, again, as I mentioned earlier, a pre-incubation step with proteinase K and lysis buffer for 15 minutes at 56 degrees. After the initial 15 minutes of the incubation time, isopropanol, magnetic beads, and the VetMAX Xeno internal positive RNA control, or template, are added to each well. After this step, the 96 dead well plate is placed back in the Kingfisher Flex so it can proceed with the remaining extraction steps. Okay, so as I mentioned earlier, 1 or microliters of the Xeno internal control are added to the sample. The amount to use may vary depending on the type of nucleic acid system being employed. The choice of internal RNA control instead of the DNA control as part of our laboratory standard procedures was based on the fact that the laboratory processes DNA and RNA templates at the same time. And these have to be reported, obviously, at the same time. Using DNA controls may be enough to trace inhibitors from DNA templates, but it may not be sufficient to trace the presence of inhibitors around RNA templates. In our experience, we find that in some cases, you might find inhibitors that only affect the reverse transcription step, but not the actual PCR step. All right, so 1 microliter of the Xeno primer probe mix is used in a 25 microliter reaction. This is obviously after extraction, we prepare the PCR reactions. And the thermal cycling protocol is performed according to the manufacturer's instructions. The least dye has an emission spectra of 660 nanometers approximately. Thus, the red channel is turned on the thermal cycler for detection. The choice of least dye as a part of our standard operational procedure allows us to differentiate the internal control amplification signal from the molecular target amplification signals, since most probes are labeled either with green, or such as a FAM, or yellow, such as a VIC. So here we have a sample of a control using the least internal control, RNA, and we can see that in this particular run, the average is 34.7 cycles. It is important to take into consideration that there might be some inhibitors present, because we use, as I mentioned earlier, we use feces that obviously carry inhibitors in most cases, and also in some cases also blood. But because we have also detected IPC values as low as 27.5. This is using specimens that are found naturally. So therefore, you expect to have some inhibitors. If you use a clean run using DNA from extracted plasmid or a template, synthetic template, then you will have CT values which will be much, much lower. This is the importance of using an internal control, because it will show you the minor differences in CT values when inhibitors are present in the sample. Our range has been determined to be up to 38.5. And again, the reason for that being is because 38.5 CT value is the limit of detection. If we have a sample that the IPC value is higher than 38.5, we tend to re-extract or re-amplify. Now, techniques to avoid inhibitors in the sample would be, again, when you restruct, you will have to use less starting material. So we lower it from 150 to 100. Or you can also add fewer microliters of the template into a PCR reaction. So this is very important, so we can get all the results on the same day, and I'm very pleased to use this product. Thank you for your attention.
Dr. Franco, thank you very much for that presentation. Before jumping into the Q&A portion of the webinar, I just wanted to bring to everybody's attention the portfolio details. As mentioned earlier, we offer both an RNA and DNA version of the internal positive control template, and that comes in both a 100 and 500 reaction kit size. And then as far as the internal positive control assay is concerned, we offer both a VIC and Liz dye channel option in both 100 and 500 reaction kits. And we do have several pathogen kits that have the Xeno IPC included in them. These are our VetMAX Gold detection kits. We have a BVDV PI, an SIV detection and subtyping, a trick detection kit, and then an AIV detection kit, and each of those are available as 100 reaction kit sizes. And then finally, we do offer all of our different master mixes with the Xeno IPC included. This is our VetMAX Plus portfolio of master mixes. So we have a one-step RT-PCR kit, a multiplex one-step RT-PCR kit, and a qPCR master mix. And each of those as well are available in 100 reaction kit sizes. So if you'd like to learn a little bit more about the Xeno internal positive controls, I welcome you to visit the web page. On that web page, as Michelle mentioned earlier, we do have a white paper which goes through the incorporation of the VetMAX Xeno IPC and Assay into existing qPCR workflows. And then if you want to get even more detail on Michelle's presentation today, we've got a full application note available online for you to download. And the title of that application note is Performance of VetMAX Xeno IPC with Variable Thermal Cycling Conditions and Enzymes. So with that, I would like to now open the floor for our questions and answers.